Super. So similar triangles, new skills. Similar triangles, before we were working with any old shape, rectangles, houses, bedrooms, stuff like that. Here we're going to just stick to triangles. Now, something you need to know is, and I'd underline this, the sum of the angles in a triangle is always 180 degrees. You need to know that. If two corresponding angles and two triangles are equal, the third one will also be equal. That's another little rule there, but 180 degrees is the sum of all angles in a triangle. You've seen this before, but may have forgotten. Two triangles are similar if any two of the three corresponding angles are congruent or the same, okay? So if you know the two angles are the same, we could say they're similar triangles. Or one pair of corresponding angles is the same, congruent, that's what that means, and the corresponding side adjacent or connected to it, right beside it, are proportional, like a 2-to-1 ratio or something like that. Two right triangles, a right triangle is one with a 90-degree corner. Two right triangles are similar if one pair of corresponding angles is congruent. That's because we already know that the other angle is 90 degrees. Now, look at this. Given these two triangles below, first of all, are they congruent? Are the angles congruent? It looks like angle C and angle N are congruent. They've labeled it that way with the same marking. Angle X and angle X, same marking. So they're congruent, they're the same. So these are two similar triangles. Once you have that, all you've got to do is say, well, side A, 5 here, is like this side that's 2. How do we set that up, guys? What do we always set it up in? Fractions. Yeah, you're making the right symbols. Line equals line. On the big triangle, I'm going to put big here and little. You guys are setting this up on the little triangle. Okay. Which, on the left side, we always try to get plain old numbers, no X's or anything like that, no variables.
The big side.
So on the big triangle, which side is like, which one do you have a measurement for? Which two sides? 5 and? Okay, well, let's use actual numbers instead of A. Let's just say 5 inches is like the 2 inches on the small, right? So we put that in here. The 5 inches is like the 2 inches. Now we want to find the length of N. N is this one. And that is just like the 7. Where do we put? I underlined which ones we're looking at. Where does the 7 go, on the top or the bottom? Top, because that's the big triangle, right? The 7 inches is just like the N on the small triangle. You guys know how to solve this. And you're gonna. Well, no, because we're gonna run out, you're gonna, after I stop recording. Because I want to make it quick here. Example 2, and then I'll just turn you loose on these. Ravi notices that a 2-meter pole casts a shadow of 5 meters, and a second pole casts a shadow of 9.4. How tall is the second pole? Now, what is this? You know how we're going to assume the pole goes straight up. I won't draw an arrow. If this is 5 meters and this is 2 meters, 2 meters, 5 meters. Right. So this is the shadow here, right? And a second pole casts a shadow of 9.4. So I know it's bigger. It's the same time of day, so the shadows should be at the same angle, etc. So 9.4 meters. How tall is the second pole? I'm going to use a T for tall. You guys would know how to set this up, right? you get the fractions. And I'm going to leave it at that. I'm going to stop the recording. There we go. And I will stop the broadcast.